statistics. Now, can you remember that I mentioned that right in the middle of the box, we have got that number 61869.21. Now, that is the second quartile, but it's also named the median. And it's the halfway point between your data, and it's also a type of average. So averages, think of those as being, if you were asked to name a typical value in your data set, the average would be what you would pick. Now, there are three types of average. First of all, we've mentioned the median, so let me jot that down and try to spell it correctly. There we go, that's better. To calculate the median, you use the median function, so equals median, open parenthesis, and then we pass it in numbers. So I go into A2 and I do Control-Shift down, I put the closing parenthesis in, I hit return, and we get the figure there of 61869.21. Now, it's difficult to see with this colour scheme, but there's another sort of average shown on the box and whisker chart. Let me select the box, and let me go to the Format menu, and then I'll change the shape fill to be no fill like that. There we go. We can see that there's a cross right in the middle of it, and it says 61495.9677. Now that is the mean, and it's what you typically think of as the average. So you add together all of the numbers and then divide by the count. The function that you use is called average, not mean. You pass it the numbers, so again, Control-Shift down, and we get the value there, 61495.968. Now, can you remember me saying that the range was quite a sensitive creature that could be pulled to either side from extreme values? Well, the mean is the same, whereas the median will tend to be very, very stable because it's right bang in the middle of your data. The mean will tend to be dragged upwards. So if I go to my richest person here with the highest salary, and then let me give them a pay rise of 100,000 first of all. Then we will return, and then just watch what happens to the mean. There we go. Did you see that increase? So we've now got 61511. Let me put on another 0. I hit return. It now goes up to 70511, so that's rapidly increasing. And if I give him another pay rise, oh, that's a massive pay rise, isn't it? It now goes up to 160,511, like that. So that's what I mean by the mean being quite sensitive to what's going on. Now, one of the reasons why I'm drawing your attention to this is because it does have some impact, I suppose, on everyday life, and in particular things you might hear on the news. You may have heard on occasions an announcement that says something like, yay, the average wages are going up. And you think, well, yes, that sounds like excellent news. But which average are we talking about? Because if all of the wages have gone up, then yes, that would increase the median, because remember, the median is the middle point in the data. What it might mean, though, is that just the mean is increasing, which might mean that the richest guy has just got a massive pay rise, which has dragged that mean value upwards. So just watch out for that sort of thing. Now let me put that back to how it was, like so. Now, the third type of average is called the mode, and this is the most popular item, or the one with the highest frequency. To give you an example of that, let me show you some more data here. where we have basically got a bunch of customers and their satisfaction on a scale from satisfaction for the rows, and then customer or the values like that. And then we would find that the mode is the one with the highest frequency there, which is 8. You can also use the mode to find the most popular group. So if I go to my quantitative pivot tab like that, for this data, we would have a modal group of 5 to 10. And we can also use the mode to tell us what the most popular item is for quantitative data as well. For qualitative data, text-based data. It's the only sort of average that will work with that sort of data. So here that will be coffee. Now, there's a function, 2 functions actually, that we can use to return the mode. If your data has got a single mode, then you can use equals mode dot sngl like that. We put in an open parenthesis, and then we pass it the data like so. If it can't find a mode because everything is equally popular, you will see that it says #NA like that. But if I was to go into the second highest value here and change it to the 98453 like that, we would see that the mode value now becomes that value like that. If you have got data that perhaps has multiple modes, you can return all of them using the function mode dot mode like that. So again, we pass it the numbers like that, and it will return however many modes there are. Now, let me see. Yeah, that's everything to show you right now. What I do want to tell you though, we have been finding a bunch of different statistics, haven't we? All of those different averages, things like the range, the smallest, the highest, all of those things. And if we were to find them all individually, it might take us a little bit of time when we'd perhaps want to be doing something else. The good news, though, is that we can use the Analysis ToolPak to return most of them all in one go. So what we do, we go up to the Data menu. We then choose Data Analysis, and then we look for the tool that says Descriptive Statistics like that. We then click on OK. We then choose the values. So I'll put my cursor in 8.1 and then do Control-Shift down to select all of that range. So I've got 8.1 to 8.101. The data is grouped in columns. It's all in a column, so that's good. Labels in the first row is something I need to check because A1 contains a label. Then I need to say what the output range is. So where do I want to put the data? I'm going to put it in cell C1 like that. And then I need to specify what to return. Now I'm going to choose the option that says summary statistics like that. And then that's going to be everything that I want to see. So I can then just click on OK, like that, and we get a ton of different statistics like so. So we've got things like the mean, the median, the mode, other things that we'll be touching on very shortly. We've got the range, minimum, maximum, sum, and count. So using the Analysis ToolPak descriptive statistics option, you can return all of those things in one fell swoop. Right, with that, I'm going to stop sharing the screen and go back to the slides window so that we can revisit all of this. Right, we've been looking at ways of describing data, and our mechanism for doing that is to use the box and whisker chart. First of all, we've got the whiskers for that chart, and this shows the range. So the spread of the data from the lowest value up to the highest. You can use the max function to find the highest number, the min function to find the smallest, and then to find the range, you use max minus min, like so. Next, we've got the box, and that deals with the middle half of the data, or to be specific, the data between the first and third quartiles. Remember that quartiles are the values that divide the data into quartiles. To find your quartiles, you use the quartile.exc function, and you can calculate the interquartile range by finding the third quartile and then subtracting the first quartile. Something I'll mention, there are also percentiles. Think of percentiles as being like quartiles, except they deal with percentages instead of quarters. And to find percentiles, you'd use the percentile.exc function like that. Then I mentioned outliers, and your outliers are going to be those extreme values that aren't typical of the rest of the data set. Something to note is that the box and whisker chart will exclude outliers from its range, so they'll be shown as separate points. And then we moved on to averages, and think of your average as being a typical value. So we've got the mean, the median, and the mode. The mean is calculated using the average function, and is the typical average where you've got the sum of the numbers divided by the count. The median is the number that's right bang in the middle of your data set, and you calculate that using the median function. And then we've got the mode, which is the most common number, or the one with the highest frequency. So the function you'd use would be the mode.single or mode.mode, depending on whether you want to return a single mode or multiple ones. And you can also find them using a pivot table. Remember that the mode is also the only sort of average that you can use with grouped data and with text-based data. And the final thing that we looked at was how you can use the Analysis ToolPak to generate a ton of descriptive statistics all in one go. So go to the data menu, choose data analysis, and then use the descriptive statistics tool to generate things like range, the averages, and a load more. So, time for an exercise then. What I want you to do is go back to the exercises workbook and then go to the third tab. You'll see again the table of the times taken to load the web page in milliseconds. Now, what I would like to know is what the range is for this data, what's the mean, and what's the median. So, find those statistics for me. When you've got them, please drop them into the chat so I can see how you're getting on. I will switch my mic off to let you get on with that in peace for, let's say, 2 or 3 minutes. And after that time, I'll be back with the solution. Right, let me see how you're getting on in the chat then. And yeah, brilliant. I can see lots of correct answers there for the range, mean, and median. And oh yes, a lot of you get bonus points as well for things like the interquartile range and the mode. Brilliant. Right, so let me show you the solution. As you have quite rightly found out, we've got the range of 2484, the mean of 1675.99, and the median of 1623. So let me share that screen of mine and let me walk you through this. So I'll minimize the demos and I'll bring up the exercises. I'll go to Getaway Demos. Let me go to my Descriptive Statistics tab like that. And what I will do is generate these using the Analysis ToolPak. So I choose Data, Data Analysis. I choose Descriptive Statistics from here. I click on OK. And I think that's the correct range and everything that I need, so I can simply click on OK. And we have got all of the statistics right there. So if I zoom in, we've got the range of 2484, we've got the mean right at the top, and we've got the median a couple below it as well. Now, just one question that I've got. When looking at averages, can the interquartile range be considered? Yeah, that's an interesting question, actually. I mentioned that the interquartile range is really useful, particularly when you have got extreme values. And you can think of the interquartile range as being like the meat of your data in effect, because it's the middle of 50%. One thing I didn't mention, but it's probably a good opportunity to, as well as the average, there's another type of mean that you can use called the trim mean, like that. What the trim mean function will do is return the mean excluding a certain percentage of points. So what that means is you can use the trim mean to get rid of those few extreme values that are perhaps distorting things a little bit. So I will leave you to look at trim mean at your leisure. And what I'll do is go back to my demos and let me go back to my descriptive statistics here. And I think what I'll actually do, I will just put the name of that function on that, because you'll have access to my workbook at the end of the course. And I'll just put it there so that you'll be reminded of which function to look for that might help you with that. Now, let's move on. We now know about things like the range, the interquartile range, those outliers and averages. But as I'm sure you know, there are more ways of describing the data. For example, if I go along to my next tab, you'll notice that I have got here 3 data sets. They all start at 20 and end at 50, so they've got the same range. But I've also got histograms for each one of those, and notice the different shapes there. Notice also that they have all got different means. Now, what would be useful is if there was a statistic that we could use that would give us some sort of indication of the shape of the data. Well, as I'm sure you can tell from this lead-up, there is indeed such a statistic, and it's called the skew or the skewness. To calculate this, what you do is put equals and then type skew like that. Then you pass it the numbers like that. If I can, I'm really messing this up. Let me backtrack there. Right, let me try again. You select all of the numbers like that. You put in a closing parenthesis. You hit return. and the skew in this case returns 0. Now, if you have got a skew of 0, that basically means that your data set is symmetrical. In practice, if you have got a skew that's between -1 and +1, means that the data is reasonably symmetric. Now, if we move along to the next one, we can see that this isn't symmetric whatsoever. We have got this long tail over on the left. So we'll work out the skew for this and see what it gives us. We put equals, skew. We select those values. We hit return, and we get -1.478. Now, when you have got a skew value that is less than -1, you call this either negative or left skew. And what it tells you is that you will have a tail of extreme low value, so a tail on the left. When you're working with skew, it's very tempting to think that negative skew refers to where the bulk of the data is. It doesn't. It refers to where the tail is, so just bear that in mind. Now for the final one, you could probably hazard a guess as to what type of skew this is. Let me type equals skew. I type the values like that. I hit return, and we get 1.127. So this time we have got skew that is greater than +1. So when you've got skew greater than +1, it means that you have got positive or right skew, and it refers to the tail that's over on the right. Now what this means is if we have got a data set, we can work out whether it's likely to be reasonably symmetric by calculating the skew. So we put equals skew. We then put those values in by doing Control Shift and down. We hit return, and we get -0.05. So that is most definitely between -1 and +1. So it tells us that the data is reasonably symmetric. And we can put on a quick histogram by going to Insert, opening up the Statistics section and choosing histogram like that. And you can indeed see that we have got quite a reasonably symmetric data set there. Now, as well as, one quick thing, backtrack. As well as calculating skew using the skew function, remember the statistics from the descriptive statistics bit of the Analysis ToolPak. Down there, above range, we've got skewness there as well. So it comes bundled with the descriptive statistics that you don't have to calculate yourself. Just use the Analysis ToolPak to generate them for you. Now, I'm going to move away from skew because there is another way in which we can describe the shape of the data. Let me get my little drawing tool like this. Roughly speaking, in about the middle of the data set, we are going to get the mean like that. Now, what can also be useful is if we have a statistic that tells us how the data points scatter out away from the mean. So effectively going a bit like that. Now, the statistics that you can use to tell you that information are called the standard deviation, like that. Deviation, that's better. And we've also got the variance as well. So we have got those two statistics. Now, as before, those are statistics that are generated from the Analysis ToolPak descriptive statistics option, but you can also calculate them by putting in equals dev.s, like that. And then you need to pass it the numbers. So again, we do Control-Shift down, put in a closing parenthesis, we hit return, and we get 18,661. Now, the standard deviation can be a little bit fiddly to understand at first, I think, because you think, well, what actually is it? What is that telling me? A way of thinking of the standard deviation is that it's like the average distance of points away from the mean. There's a little bit more to it than that, but that's a way of thinking about it. Now, the variance is the square of the standard deviation, and you calculate it using equals var.s, like that. Again, select the numbers, and it returns that colossal number there, 348247762, like that. What you tend to find is that the mean and the standard deviation will often work together because they are like the superstars of the statistics world. We'll have a look at a use for them very, very soon, and we'll also carry that into next week as well when we look at probability distributions. But now, though, I'm going to once again stop sharing my screen and we'll go to the slides window to review this. So we're looking at ways in which we can measure the way in which a data set will vary in some way. And first of all, we've got the skew or skewness, and that is a measure of how symmetrical the data is. You can calculate it using the Analysis ToolPak, or you can use the skew function. If you've got low skew, it means that the data is reasonably symmetric, and you'll have a skew value between -1 and +1. If you have got positive skew, it means that there is a tail of positive values over on the right, and your skewness will be greater than +1. And you've then got negative skew. And I've got a typo there, skew mess. Yeah, that's very good. If your skew mess is less than -1, it means that your data is left or negatively skewed. So in this case, your tail of values appears on the left. Now, the other thing we've got are this variance and the standard deviation. These measure how the data scatters away from the mean. And the larger that number is, the more the data is scattered. It is quite useful because you can use it to compare different data sets and see if they vary by the same amount or if one is far more scattered out than the other. To calculate them, you can use the dev.s and the var.s functions. And quite conveniently, you can also get them from the Analysis ToolPak's descriptive statistics option as well. So the skew, standard deviation, and variance can all be generated from that tool. So exercise time again. At this time, I want you to go to the 4th tab of the exercises workbook. You'll find there a table of amounts. I would like you to tell me what the standard deviation is and also what the skewness is. And I'd like to know what that skewness value tells you about the data. So have a go at that exercise. When you've got answers, please drop them into the chat. I'll switch my mic off for a couple of minutes, I think, to let you get on with that in peace. And then I'll be back with the answers. Right, so over in the chat then, yeah, I can see that we have got skew and standard deviation figures coming in. And yes, I agree with those figures. So the standard deviation will be 10,155.9. The skewness is 0.725 and so on. And because it's between -1 and +1, then it's considered to be reasonably symmetric. You can see, though, that because it's edging towards +1, we have got the beginnings of this extra tail appearing over on the right for that positive skew. So it's still considered reasonably symmetric, but it is heading into positive skew territory, shall we say. So let me just quickly run through that with you. Let me go and share my screen. And I can see we've got my bad drawing there, so let me minimize that. And I will bring the exercises up. And what we'll do is choose data, data analysis, descriptive statistics. We'll click on OK. And I think that's everything already set up, so I can simply click on OK like that to return the statistics that I'm interested in. So we've got standard deviation right there and skewness appearing a little bit below it like that. Good. Now, I mentioned that the mean and standard deviation together were the sort of rock stars of the statistics world. So I'm going to show you an application of how we can use these, and there'll be more next week. What we have got here are the sales figures for two areas. So I want you to imagine that you run this company and you have got those two sales areas. Now, because you're a very, very generous person, what you have decided is you are going to award your best salesperson with a prize. So if we have a look at the area A sales, first of all, and if I sort that descending like that, we can see that the top person there got a sales value of 126,616. And over in area B, we have got the top person there, we've got 11,810. Now, you would be very, very tempted to say, well, come on, the person from area A, they massively outsold the area B person. But there's a little bit more to this story. If I scroll down quite a long way, then you'll see that I've got some statistics there for the two areas. And in particular, look at the value for the mean. And we can see that that is 62,225 for area A, but for area B, it's only 5,103. So one way of interpreting this is that actually making sales in area B is really, really hard. So there's no way that someone from area B is going to reach the dizzy heights of the area A people. So what we want to do is work out how well the top person from each area does relative to everyone else in their team. Now, let me sketch this out for you first so that we can see what we'll be doing. First of all, we have got our first set of data for area A, and if I try and draw that in a very wiggly sort of way, then we have basically got their figures appearing on a curve like that. Okay. And then we have got our area B people, and they will appear on the chart looking a bit like that. And it may not be that easy to see, but we have got the mean for each one of those appearing in the middle of the curve, and we have got the green area B line appearing far more towards the zero here. because area A will massively outsell them. Now, what we want to do is put area A and area B on a common scale so that we can compare them. What we effectively do is move area A so that it is centred right there on the 0, and we'll also squash it in a bit like that. And then what we do is we pick up the area B stuff like that, and we put that on the same scale like that. What we then do is look at how their high values translate, so we can then compare the two using that. Now, that might sound a little bit tricky, but that is a function that will help us. What we do is we generate the standard score, which is also known as the Z or Z score, calculate it by using the standardise function like that, and you pass it three things. The score that you want to translate, which comes from cell B107 there. You then pass it the mean of that data set, which is in 108, and then you pass it the standard deviation for that data set as well. So we put all that together, we hit return, and under that standardisation, the person with the highest sales got a score of 2.64. Now we do the same thing for area B. We work out the standard score by typing standardise. We put in the maximum sales value there for F107. We then pass it the mean, and we pass it the standard deviation, and we hit return, and we get 3.42778. So, what this tells us is that relative to everyone else in their data set, actually the person in area B did better than the person in area A, because we have standardised their scores, their sales amounts, and the area B person has got the higher score. So that is one use of using the mean and standard deviation together. It lets you compare different data sets and see how well people do relative to the other people in their group. So we will go and just review that. So let me stop sharing my screen so we can go over to these slides. What we have got then are standard scores, also known as Z or Z scores. These are scores that let you compare figures across data sets, and it's a way of standardising figures using the mean and standard deviation. Technically speaking, you calculate the standard score by taking your number, subtracting the mean, and then dividing the whole lot by the standard deviation. The good news, though, is that you've got that standardised function in Excel that you can use instead. Now, at this point, I did have an exercise for you on calculating standard scores and applying that. But I have still got sampling to get through today, so I'm going to skip past this exercise, and I would encourage you to have a go at this in your own time after the course has finished. So with that, what I'll do is skip over to sampling. Now, so far, what we've really been focusing on is data that we have got in our worksheets already, and then using statistics to generate, using statistics to describe that data. And we've seen how statistics like skew and variance and average can tell us key points about that data. What sampling is all about, though, is getting hold of that data in the first place. Now, in general, you want to use statistics to solve some sort of problem or get a better understanding to help you plan and make decisions. And you need to bear that problem in mind when you're thinking about what data it is that you need to gather. As an example, if you're developing a new kind of cat treat that you want to take onto the market, you want to find out how cats will respond to it. So there's no point in giving it to fish. It's only the cats that you're interested in. Now, once you've decided what data you need to gather, then we move on to the next thing, which is the population. Now, the population is the ideal target group that you want to examine. So it's the entire group. So if we're looking for cat reactions, then the population would be all of the cats. Now, most of the time, it's not actually possible to gather information for an entire population. So in this case, it's not really going to be all that practical for us to give a cat treat to every single cat in the entire world and find out what each cat thinks of it. What you do instead is you use a sample. Now, a sample is part of the population. So instead of trying out the cat treat on every cat in the world, we try it out on a group of them, which would be our sample. And we then use that sample to tell us stuff about the population. In particular, we use it to estimate population statistics. What we can do is use the sample to make some educated guesses, and we can use the sample mean as an estimate for the population mean, and we can use the sample standard deviation as an estimate for the population standard deviation. Now, there's one catch. This works just so long as the sample is representative of the population. So, what do we need to bear in mind? The first thing is you need to bear your sample size in mind. It's got to be large enough. So we can't say just test our cat treat on one cat, because that's not going to be enough. We want to have quite a few cats. In general, the larger your sample size, the more likely it is to be representative of the population. Now, there is a question about how big your sample needs to be. It does depend on how subtle the things are that you're looking for. In general, 10% of the population is quite often reasonable. What you may also find is that between 100 and 1,000 is quite a reasonable size sample. But as I say, it really does depend on the situation and what you're wanting to find out. What you can find is there are sample size calculators online, and they can be used to help you determine what is an appropriate sample size in your situation. So it's worth just having a search for sample size calculators and seeing what you can find. Now, the other thing to bear in mind is bias. Now, bias is when you collect your data and you have a sample, but that sample isn't a true reflection of the population. The problem with this is having a biased sample can lead you to making